at sorting today, and with sorting it's important that you understand how the algorithm is going to work. So we've got 6 playing cards there. Clearly they're not sorted at the moment, and one of the issues people have when they're new to programming is actually working out what the algorithm should be. So if you were asked to sort these cards, you could very quickly put them in order, and you'd probably do it in some sort of ad hoc way by saying, right, these are the high cards, these are coming down here, and these are the low cards and they're going down there. And when we are doing things like that, it's relatively easy. However, if I put them back in some sort of mixed up order, then we can see that we'll leave it like that. So we can see how we actually go about doing things. If we look at these cards again now, and we think about how we could actually sort these into order. So one way we could do it is by start at this end, and we could say, right, are these in the right order? Yes, they are, so we'll leave them as they are. What about the next 2? No, that one's in the wrong order, so 10 and the 8 need to swap. And we'll take the next 2, 10 and the 5 swap. The next one, okay, and then again. And what we've actually done is we've actually moved the 10 from its starting position up to here. So it's the highest value card has bubbled, if you like, to where it should be, and that's what a bubble sort is about. And the way it works is we then start back over here and we say, are those in the right position? Yes, they are. That the 8 is higher. Now the 9 is higher, so they stay where they are. Move to the next 2 and then we swap over. 9 and 10 are okay. Back to this end, these 2 appear to be sorted. So move to the next 2, the 5 and the 8, and whoops, the 5 and the 8 is in the right order as well. The 2 and the 8, they swap over. Now we look at the 8 and the 9, those in the right position. 9 and 10 are in the right position. So we're almost sorted, but we go back to the beginning. 4 and 5 in the right order. 5 and 2, those need to swap. And nothing else then needs to swap. So back to the beginning, 4 and 2 swap, and we're actually in the right order. So we can see a bubble sort is not the most efficient way, but it will actually get us sorted. And I've actually not done all the comparisons as I've done that. Okay, so that's the bubble sort. Okay, so let's have a look at the algorithm that we need to create. So first of all, we had a set of numbers, although they were playing cards. I get this syntax right. And our playing cards had they were in the following order. We had a 4, a 10, a 8, a 5, a 9 and a 2, and we actually went round a number of times. So we're going to need a for loop, and we'll go from 0 to, and we're going to have some sort of counter. So this is the number of times we actually went round through the sets of cards. So how many times did we start from the beginning and go round? And we had to do it, although it wasn't perhaps clear initially, but we would do it the number of times that we have cards almost. We can actually take one off, so we can actually go around we need to check every time. Even the last time we went through, we had a single card that needed to swap places. So the number of times we're going to go through, so count, we're going to set equal to the length of the numbers, but because we're doing comparisons, we can actually subtract 1 from that. Oops, made a mistake there. So we're going to go around however many cards we've got, or how many numbers we've got, we need to go around that many times minus 1. Then each time we go round, jumped a long way along, each time we go round we need to go through the full list comparing them, and again we need to go around each one. So we start from the one end of the list and we compare them, and then we compare the next two and the next two and the next two. So it's however many numbers, or in our case cards, we had, that's how many times we need to go through the list. And each time we go through the list, we can say if that number I just realised I should have the word numbers there. And we're going to go, so that current one, is it greater than the next one in the list? Okay, so we check to see if our current number, so our first card or number, is it greater than the next one? And if it is, we need to swap them out. So if it is, what we're going to do is have a temporary variable and make that equal to the current one, and then the next one equals sorry, let me get the right way around. So our current one equals the next one, so we've put the current value that we're looking at into a temporary variable. We've then copied the next one in the list into the current one, and then we're going to just move that one back. So j plus 1, which is the next one in the list, is going to have the temporary variable, which is what we had initially, and then we just need to end that. Okay, so I think that should work. So we're going to go through the list of numbers or cards, however many numbers we've got in, minus 1, because we're doing comparison, so we don't need to go that number of times. So that's how many times we need to go through the whole lot. Each time we go through, we need to compare each one in the list, and when we compare them, if the current one is greater than the next one in the list, then we swap them around. Okay, so that's the algorithm that we're going to use. So the next thing to do will be to write that out in Python. Okay, to write that out in Python then is, we'll use the same variable. We're going to say numbers equals, and we'll put the same numbers in. We're going to use our list. So we're going to have 4, 10, 8, 5, 9 and 2. And we're going to set count equal to the length of our list minus 1. Then we're going to have our first for loop. So we're going to say for I in range count, and then for our second loop, j in range count, the wrong bracket, there we go. So what do we need to do? We need to say if numbers, and we're going to have our j is greater than numbers j plus 1. We're going to do our swap. So our temp equals numbers j, numbers j plus 1 equals numbers, sorry I've got that wrong way around, numbers j equals numbers j plus 1. And finally numbers j plus 1 equals temp. And just to prove it's all worked, we can print numbers. I suppose it might help if we actually printed out numbers right at the top as well. So we can see if our sorters actually work. So that's our algorithm converted into our Python program. And if we just run that, okay, I've got a mistake somewhere. Okay, let's try running that again. Don't know how many mistakes I've made. Okay, and we can see that our bubble sorters worked. So we've gone from 4, 10, 8, 5, 9, 2 to 2, 4, 5, 8, 9, 10. So that's our bubble sort. Of course, this sort would work if we change the numbers or we add more numbers to it. So if I go back to my program here and I put in some more numbers, so now I've got a much longer list of numbers. I run that, and that list of numbers has also been sorted into the correct order. Notice even if we've got numbers that are the same, it still deals with those. Okay, that's all for this video, and the next one we'll probably look at another sorting algorithm, which will be the insertion sort.